Hello and welcome to today's webinar. I'm Linda Brissenden, Professional Development Consultant for the Illinois State Board of Education. And today my colleague Anita Reed, a math practitioner, and I are pleased to present this webinar. We'll share our emails with you if you have questions or want to contact us later. Anita, who currently teaches in Lewiston Community School District, is experienced as a curriculum writer for the Model Math Curriculum Project. She also presents webinars and conferences and is a board member of the Illinois Council of Teachers of Mathematics. This is the second of 5 teacher-to-teacher webinars, and ISBE is pleased to have practitioners share their expertise and passion for teaching math. Nobody does it like you all do. We value your input along the way, so please type in your questions or comments as we proceed, and I'll do my best to pass those along to Anita to respond to as we can. To help Anita adjust the emphasis of her presentation, we're going to take a couple of polls today, and you'll be able to respond to the questions with the one that best describes your backward design familiarity and use. The first question is, I know what they are, where they can be found, and I've actually taught a unit using an MMC lesson. The second response is I've used some information from them occasionally. And the third one is I've never used any of that information. If you could just select the one that best describes you. And we'll move to the second poll after we kind of tally the responses here. All right, we're closing the poll now on the first one, and it appears that just about 70% of you have never used any of the information of the Model Math curriculum. So that means there's a lot to learn today. We'll go to our second poll question, and that has to do with the backward design familiarity and use. And so as you look at these items, the first one says, I know all about backward design, BD, tuning in to see what's new. I know a little bit about it. I use backward design occasionally. Or I want to learn what backward design is and how I can apply it in planning. So if you'll go ahead and poll, please. It shows that about 60% of you want to learn what it is and how you can apply it in planning. So you are just at the right place, and the rest of you who know a little bit about it and the rest of you who have used it occasionally can certainly help us by sending us some comments as we go through the presentation. I'm going to turn the program over to Anita, and she's going to proceed through the information, and we just hope that you will take time to participate along the way.
Thank you, Linda. Good afternoon, everyone, and welcome to today's webinar. Let's begin by going over today's targets, which are, what are the 3 main parts of the backward design? If you wanted to read more about backward design, whose work might you choose? How is a standard deconstructed or unpacked to determine targets for learning? And how might you explain the alignment of your lesson plans and assessments to the standards? To begin, I want to look at an article straight off of the ISBE website. This is important. It summarizes the history of the need for and the development of the Model Mathematics Curriculum Project. I want to draw your attention over to the right-hand side where there's a list of schools who are currently piloting the Model Math Curriculum. And perhaps you see some schools in that list who either piloted last year or who are currently piloting this year that are near your area and would be able to assist you with any further questions nearby, and perhaps maybe available for some classroom visits. Since some of you are familiar with the Model Math Curriculum, about how many units would you find there? You can just keep an answer in your head. And also, about how many assessments will you find there? Well, you're going to find 88 units, 72 lessons, and 516 assessments. That's as of January of 2015. These units have been built on the learning progression. They have considered the evidence tables. They're aligned to PARCC. They include rigorous, engaging math tasks. They have been piloted and reviewed. And this set of resources spans math courses for grades K through 8 and integrated math 1, 2, and 3 at the high school level. In addition, the model math curriculum resources include parent letters to help promote parent involvement and understanding. Why might I want to use these resources? Well, as we mentioned, they are aligned to the new Partnership for Assessment of Readiness for College and Careers, PARCC, exams. In addition, 3 of the 4 lessons submitted to the National Peer Review Panel have received the highest exemplary rating, and we also include the learning progression to ensure coherence throughout. In case you're wondering where to find LiveFinder on the internet, which is the online host that houses our resources, here are some specific directions to locate them. You can either access them through the ISB site or go to IllinoisClassroomsInAction.org, and you want to choose the green Model Math Curriculum button. This webinar will be more meaningful if you will type in questions or comments as we proceed. The questions you type in are not viewed by all viewers, so please let us know about success your students are having using the Model Math Curriculum resources and what else you would like to see there, and so on. If you have questions, type them in as we go, or be sure to email them to me or Linda at the addresses listed at the beginning of the presentation. So how do I begin to build a lesson in mathematics using backward design? Well, I know as Illinois educators you are all familiar with the new Illinois Learning Standards, but these are quick links to them and also to the Math Progressions Framework, which you can download for reference. Both of these documents are instrumental tools for backward design planning. Grant Wiggins and Jay McKee are experts who have promoted the backward design model for the past decade as part of their UBD, or Understanding by Design framework for lesson planning. The model has 3 basic components. The first step is to identify desired results, which are the big ideas or skills we want students to know or be able to do at the end of the lesson. Then the next step is to select or design the evidence that will be used to assess whether those desired results, knowledge, skills, understanding, or a balanced variety of conceptual, procedural, and applications has been achieved. Then the lesson plans or learning experiences are developed that align both to the standards and to its evidence, which is the assessment. Students are assessed, and we have proof that they either know or need more instruction on the knowledge, skills, or application that the standard sets forth. So a quick quiz of Target 1. Which of these is the recommended order for planning when using a backward design planning process? 1, target, step-by-step procedure of the lesson, then assessment. 2, step-by-step procedure of the lesson, target, then assessment. 3, target, assessment, and then step-by-step procedure of the lesson. Go ahead and make your choice. And the correct response was 3. The standards provide the target, what is to be learned, content, and skill. Then we designed the assessment, and then we designed a step-by-step procedure of the learning experience. So wait a minute. If you have aligned your assessments to the standards, which outline what concepts or skills you are supposed to teach, why would you not teach to the test? This is not teaching the test. As professionals, we know we do not teach the exact items on the test, have the students memorize the exact items on the test, and then rotely respond. We want them to think. We want them to understand the concepts and skills and be able to apply what they have learned in real-world situations. Questions that I, the teacher, am asking myself. The most important question is, do I thoroughly understand what the standard requires and what is expected of my students? Other questions may be, what engaging strategies will I offer students to move them toward mastery? What authentic experiences or connections might I include to make learning math real to students their age? What differentiation and or accommodations will I need to consider? Because we all know our students vary in levels of understanding, attention spans, readiness. Next, what misconceptions might they have? And finally, what tools might you use to make the learning more concrete and participatory? So here is that lesson planning thinking process modeled. Everything it seems has an acronym. Here is mine, LPTP. That stands for Lesson Planning Thinking Process, modeled for you. Let's take a look at LiveFinder and pull up the third grade unit we will take our lesson from today. So as we look at the unit plan for Grade 3, Unit 1, Addition and Subtraction Applications, I would ask you, where do these learning targets come from? As you can see, we have the standards for this unit listed in the desired outcomes box. Did you say the targets come from the Illinois Learning Standards for Mathematics? If you said that, give yourself a pat on the back today. So back to the lesson planning modeling. 3MD is a measurement and data domain for third grade. These are two of the big ideas in this domain for third grade. There are three additional big ideas related to geometric measurement under 3MD, measurement and data. There are two related cluster standards connected to the standard 3MD1 that we will see on the next slide. We are looking at one standard of 10 that represents 5 big ideas. These standards define what it is third graders need to know and or be able to do in the domain of measurement and data. Now, the italicized standards are cluster standards. We know from our big idea that, for one thing, we are going to be solving problems involving measurement, in this case of time intervals. Also, estimation of time intervals. Notice there are additional parts to cluster standard number 2 involving volume and math and addition and subtraction applications. But in order to correctly unpack these standards and get to the exact skills being assessed, we will only focus on the first cluster standard today. For today's purposes of demonstration, we determined that the underlying standard will be our focus for 5 to 7 days of instruction. We will teach measurement and estimations of liquid and volume and masses of objects, but at another time during this unit. We will also expect students to be able to represent data and interpret it, which is another standard in that domain. And we want to practice that standard as often as we can. It is good to integrate more than one standard in lessons whenever we can. Okay. You may stand and stretch if you need to. That was a lot of information. And now we're going to dive into deconstructing the standard. Deconstructing the standard, breaking it down, taking it apart, determining teachable chunks. And that's why we focused on just the elapsed time section of the cluster standard instead of looking at the volume and mass portion, because that does require different instruction. Next, we are going to look at that standard more closely and extract the big ideas, which will become our learning targets. What are the essential knowledge or skills which students will be expected to know about or do? We're going to use a process called deconstructing or unpacking a standard. In other words, we are going to analyze the standards and locate its key parts. First, we look for the verb or verbs in the standards. What does it mean to measure? What does it mean to estimate? A quick class discussion or clock activity can show you which students know how to measure an interval of time and how to estimate intervals of time. Your observations from this sort of pre-assessment can inform you as to which students will definitely need more assistance as you progress and which ones already seem to know. In addition, ask yourself, what will we be measuring and or estimating? And the response is time intervals. So what assessments do you think would be appropriate to use to measure student mastery of this standard? Take a moment on your own, perhaps with others that you're sitting with, and jot down some assessments you could use. Maybe even send us an idea or two on the chat box. As you're thinking about that, we will continue to work on the first standard. Again, I am modeling the lesson planning process. Questions about the learning experiences I will design. How will we review the standard for academic vocabulary teacher review? What do students already know about time units, such as hours, minutes, seconds, and time intervals? Next, do students know how to represent any general addition problem on a number line diagram? Or maybe, what is a number line diagram? How can we ensure the assessment then aligns to the standard? If we want to use some of the same vocabulary from the standard itself, you might ask yourself, does this assessment tell us that students are moving toward mastery on this standard? So what assessments did you envision? The obvious, perhaps a number line diagram, since it was mentioned, or maybe a team card sort with vocabulary terms and definitions, some class observations of estimations of time intervals students make using one big clock, or perhaps some of the Model Math Curriculum Resources individual observational checklists as you observe pairs of students using a small individual clock to represent certain time intervals that they would perhaps randomly draw out of a box. Now, students also need to be able to write time to the nearest minute. A suggestion is that students would progress through a gallery walk of set clocks and write their estimations on a piece of paper. Students also need to solve word problems involving addition and subtraction of time intervals in minutes. So how about an authentic situation? You are playing the Clash of Clans. You began at 10 a.m. House rules say you can take a 5-minute running or exercise break every 15 minutes, and you cannot play more than 90 minutes a day. If you have to go somewhere at 4 p.m., how many minutes will you have actually played between 10 and 4? Are you over the limit? Okay, another quiz. The next slide has one question to see if you can tell if an assessment is directly aligned to the standard being addressed. And go. Examine the standard and the 3 assessment suggestions on the screen that follows. Determine which of the 3 types of assessment items is more likely to provide the aligned evidence of student growth the standard requires and affects more student involvement. I'll give you 30 seconds. Now the standard is find the area of a rectangle with whole number side lengths by tiling it and show that the area is the same as it would be found by multiplying side lengths. Which of the 3 will give you the most directly aligned assessment item? Would it be A, write a half-page essay describing how a rectangle and a square are related, B, measure the pictured rectangle using a ruler and determine its area, or C, represent graphically a process to prove that this rectangle's area is the same as multiplying its side lengths? If you chose C, you are correct. The others relate to rectangles but are not thorough enough to determine the item is aligned to this specific standard. So looking at the standard, we see the words in red, which help us deconstruct the standard. What type of assessment might be considered to measure the skill of telling and writing time to the nearest minute and measuring intervals in minutes? What else will the students be expected to do? Note that they not only have to tell time, but they have to know how to express time in writing. There are specific vocabulary terms that will be important for them to understand, such as nearest minute, intervals, time intervals, representing, number line diagram, time units, addition, and subtraction. This is a major standard for third grade. It is a complex standard in that they also have to solve word problems involving addition and subtraction of time intervals and minutes, and as one example, they have to represent the entire problem on a number line diagram. So we have established the targets. Already acquired skills would be addition and subtraction problem solving to create and interpret picture and bar graphs. Understanding that information can be represented in a bar graph and a picture graph form. Then these graphs can be used to help us solve 1- and 2-step math problems. Note again that this standard is a major standard. So in planning our assessments, we will need to prove to us that the student is proficient in using these skills. We will need to assess these skills often. We can use pre-assessments to check where students are starting in this knowledge and skills, formative assessments along the way, and summative assessments at the end of the learning to document mastery. We'll keep moving along to step 2 of the backward design process. So, what assessments do we determine are needed, and how will we ensure that the students are proficient to meet the standard? And when will this skill be assessed on PARCC? If you said, we need some evidence that students can tell time to the nearest minute and solve problems related to that, you are correct. Telling time to the nearest minute and solving problems involving elapsed time will occur on the PBA/MYA and the EOY. Now, the EOY, end of year, is technically not given at the end of the year because the EOY PARCC test is administered during the window this year, April 27th through May 22nd. Once again, this is a major standard, so it gets a lot of attention for third graders. Let's look at a sample PARCC item for this exact standard. It's called Patricia's Reading Time, and I like this sample because it gives us not only a look at the assessment item, but then there's kind of an analysis after that I want to share with you. So here's the problem for Patricia's reading time, and it gives her 3 intervals where she's reading on 3 different days and asks how many more she needs to read for the rest of the week. There again, it's not just a 1-step problem, but a 2-step problem. Note that this item includes an item analysis at the end. As I scroll down, you'll be able to see that. It includes the evidence statement depicting the exact standard that it was assessing. It depicts what type of PARCC assessment problem it is. It's a type 1, including that it's worth 1 point. Again, it identifies the standard, that it is major content, and we'll talk on this in just a little bit, but it identifies which math practice standard is also involved in this assessment item, which is math practice number 4, modeling. Then there's a description of the item, and again, a little bit more on the scoring information. We see a balanced representation of procedural skills, conceptual knowledge, and application present in this assessment item, demonstrating the rigor of the standard and the assessment. Okay, I guess we're going to talk about the math practice standards now. There are 3 practice standards for this lesson, and they are making sense of the problem solving and persevering in solving them. Next, modeling with mathematics, which we just saw on the assessment item. And 3, using appropriate tools strategically. Now, for me as a teacher personally, I always turn to math practice standards for more or less inspiration when I am stumped writing a particular assessment item, or even a task down the way. The math practice standards often jumpstart my thought process. For example, one of my favorites is Practice Standard 4, Model with Mathematics. So if I turn to this practice standard for ideas, I might write an item involving collecting data, because anytime a student collects data in real time, that puts them in the math right away, their buy-in and connection value soar from that moment. Versus using already collected data, and in either way, I would have the students model elapsed time then using data provided or data collected, and possibly have them do this on a class-made manipulative. Now, the assessments that you choose to use, you can select from some that are already created. Many times teachers ask, do I have to create all of my assessments for this from scratch? And the answer is no. We want you to use the resources that you have available. Now, sometimes you will find an assessment that is ready to use as is, or that would be with a little bit of tweaking. And so what you need to keep in mind when you look at assessments, you need to check the assessment for quality. Are there enough items provided so you have adequate proof of mastery? If your students complete the assessments you have selected, will you know they understand the concepts and or procedures of the standard and can apply knowledge to real-world situations? Next, and this is a big one, as I have found, drawing assessments from various sources, are the directions clear to the student? Next, as equally important, is the answer key correct? Also, you might want to consider, do you need a rubric to assess a bar graph, for example? Do you want to pre-assess to determine what they already know? And this is a huge piece. In my everyday instruction, I pre-assess every single unit, and oftentimes I pre-assess specific lessons, because it really does give us some great insight. Also, do the items require thinking more than just rote recall in order to respond accurately? More or less, is there rigor present? Are we assessing conceptual, procedural, and application knowledge? And lastly, is there only one correct response, or might there be other ways to express answers that are just as correct? So what you're seeing is the assessment plan provided for this particular unit, and it shows us formative, summative, and self-assessments that are included with this unit. And for some reason, there aren't any pre-assessments listed, but generally, all of the model math curriculum units have every assessment included as far as type-wise. So there's a type of pre-assessment, a type of formative, several types generally, often more than one summative, and a couple of opportunities for self-assessment to measure the student's knowledge of where they're at with the material. Okay, let's take a look at one of the assessments included in the model math curriculum. We're going to look today at an assessment in grade 3, unit 1, elapsed time. And this is a wonderful assessment because, as you can see, well, there are 2 problems. And what I really like about this assessment is that the very first line in the directions is pick your own strategy. And so to me, this opens up many possibilities for students who may not be able to solve a problem in exactly one method. So the directions go on to say you can use an open number line, a chart, an addition or subtraction sentence, or any other strategy to solve these word problems, but be sure to show your work. In addition, students could use a combination of procedural and conceptual knowledge, or they could use math practice 4 and model the situation, say, on a number line. Also, a benefit with this assessment is that 2 types of problems are given. One is a problem where elapsed time is given, and students must work or model backwards to calculate a departure time. For example, problem 1. The other is a situation where elapsed time has to be calculated or modeled. In any case, it is a great example of rigorous assessment, allowing for any method of solution and presenting the standard in more than one way. Moving on to step 3, planning the learning experiences. Now keep in mind we're talking about standard 3 MD cluster strand 1. And so this is actually the model lesson that's included in the model math curriculum. Let's go ahead and look at the lesson plan for elapsed time as is included. And as you can see, this is what you can see right now is the overall lesson plan. And I'm going to point out a few of my favorite parts of this lesson plan right away. First of all, the first thing we see is the targeted standard. And as we've been discussing throughout the webinar, this is the standard that we're focusing on today. Tell and write time to the nearest minute and measure time intervals in minutes. In addition, solve word problems. Now, keep in mind the previous slides, just prior to this, we were looking at the assessment, as that is step 2 in the backward design process. And we just looked at an assessment that would, in fact, assess the standard. I like how the student-friendly targets are written in this column. Not only is it beneficial for students, but it's also beneficial for parents who might have difficulty understanding the mathematical language. Moving back over to the left-hand column, it's always good to note which math practices are included in this lesson. And then also listed here are the supporting content standards. As we mentioned earlier in the webinar, these standards, we're not focused on these for for this particular lesson that we're writing. Moving down, we see evidence of where the rigor is occurring. So conceptually, students will develop the concept of elapsed time. Procedurally, students will tell and write time to the nearest minute. And the application is students modeling elapsed time on a number line, which again goes back to practice standard number 4. I just love how everything is so interconnected, and I love the design of this lesson plan so that you can see it all laid out at once. Here again is a vocabulary section next, and the vocabulary that students will have to be familiar with and use readily in their math conversations that take place during the lesson. So it's nice to have it all located in one spot. Next, we have the evidence of learning. Again, that was step 2 in the backward design process, and this gives us all of the assessments for the entire lesson, not just the segment that we might be talking about. As you can see, there's a pre-assessment involved. There are 2 formative assessments that we would give along the way, and then there are 2 summative assessments for more towards the end of the lesson. Keep in mind that these are noted by segments because this lesson has been divided into several segments. Lastly, there is a self-assessment piece that students can use along the way to assess their own knowledge. And this can be quite telling, I have found in my classroom. As we discussed earlier in the webinar, there are the 4 types of assessments that we can use as our evidence: the pre-assessment, formative assessment, summative assessment, and self-assessment. Okay, moving on down, we get into the actual meat of the lesson. And here we have segment number 1. Now, keep in mind that the time frame for this is 5 to 7 days. And that's listed up here in the corner. So in segment 1, we believe it will take 50 to 60 minutes. And this is, of course, whole group instruction. I love that the resources are listed here in the right-hand corner, including the 2 books for connecting ELA with our math standards. Here's our focus. Here is our math practices to look for in this segment. For example, math practice 1, 4, 5, and 7, and specifically how we might find them within the lesson. Here's a differentiation for enrichment for students who are ready to move on, and differentiation for remediation. Now, they recommend the book It's About Time by Stuart Murphy, and there are suggestions there as well. There's also a box devoted to potential pitfalls that students may have as they are proceeding through the lesson. Next, we have the steps outlined. There's some optional tasks or activities. We have some skills that we can review. I also like this box over here for teacher notes and reflections. As I copy these lesson plans out and adapt them for my own personal classroom, I often write over in this column so that I know what worked well and what worked not so well for next year, in addition to how I might do things differently or possibly write down other resources that I used for that point in time. And then here's a make a clock activity that you can use. There's just so much to draw from here. And then we go into segment number 2. And in segment 2, there's a very engaging wrapping the clock activity that really helps the students understand that when we represent time on a number line, if we're talking about hours, then it goes from 1 to 12. Versus if we're talking about minutes, our number line goes from 1 to 60. And again, math practices, focus, the differentiations, it's all here. A little more potential pitfall in this segment, but I believe it's all very easy to follow and very complete in its intent. Now, as we're going through these lesson plans, keep in mind that we want to ensure rigor. As in, conceptually, students will develop the concept of elapsed time. Procedurally, students will tell and write time to the nearest minute. Students will determine that the elapsed time using analog and digital clocks. And this is pretty key because many kids don't know how to use an analog clock. Lastly, application, students will model elapsed time on a number line. How much time should be spent on this unit? Well, this particular lesson for elapsed time will take 5 to 7 days out of the entire unit, which should take 3 to 4 weeks. What are some additional resources for integrating ELA with math? Well, a couple of books are It's About Time by Stuart Murphy and Game Time by Stuart Murphy. Both of these books are suggested in the actual lesson plan, and I believe the first one is the opening activity for the story that they use to start modeling elapsed time with the clock. What other resources are available to me? Well, as mentioned earlier, IllinoisClassroomsInAction.org has a variety of resources that you can use. Also, The EQUIP rubric is found at this website. EQUIP stands for Educators Evaluating Quality Instructional Products. And lastly, a website called Achieve the Core will also serve as a great resource. Now, you can use the EQUIP rubric to assess your lesson for quality, to be sure that it's rigorous, aligned, and quality. For those of you who would like to check out other sources to extend your understanding, you can also look at corestandards.org and illustrativemathematics.org. Now, there's a wide variety of tasks on illustrative mathematics. I know some teachers research there to get ideas for assessment items. Some teachers directly will use some of their items as well when you're writing your own, but it is a very valuable resource as well. Okay, let's see what you have learned, or let's review today. Reviewing the targets. What are the 3 parts of the backward design? Also, if you wanted to read more about backward design, whose work might you choose? Next, how is a standard deconstructed or unpacked to determine targets for learning? And last, how might you explain the alignment of your lesson plans and assessments to the standards? What are the 3 parts of the backward design process? 1, identify the desired results from the Illinois Learning Standards. 2, determine acceptable evidence in the form of an assessment or possibly a culminating task, which can serve as an assessment. And then 3, plan the learning experiences and instruction, as in your lesson plan. Target 2, if you wanted to read more about backward design, whose work might you choose? Did you say Grant Wiggins? Did you say Jay McTee? As an extra credit question, in what lesson design framework do we find backward design? Give yourself another pat on the back if you said Understanding by Design, or UBD. Target 3, how is a standard deconstructed or unpacked to determine targets for learning? First of all, find the verbs in the standard. Then list the targets the students are to attain. Determine the level of thinking required for each target. And look for possible assessments that the standard suggests. And as a side note, be sure you have enough assessments or assessment items to prove mastery. Finally, target 4. How might you explain the alignment of your lesson plans and assessments to the standards? Start with the standards, which relate to conceptual understanding, procedural skills, and applications students are to know and be able to do. If you design your assessment so that students can meet the targets of the standard, then your assessment is aligned. We'll take some questions if you have them, but we want to thank you for attending. And the next webinar in the Teacher to Teacher series will be Tuesday, March 24th. The topic will be writing balanced assessments. And on the next slide, we have the remaining dates and topics for the rest of the Teacher to Teacher series. In April, we'll be looking at finding mathematical tasks within and beyond the Model Math curriculum. And lastly, in May, we will look at writing your own engaging mathematical tasks.
Okay. Anita, we have a question here, and I know you can answer this, but are there lesson plans on that Model Math curriculum site for every unit?
Yes, there are lesson plans for every unit. But, for example, some units are 3 lessons long. And by a lesson, we have to understand that that does not mean just a single day lesson. Many of our lessons are multi-day lessons, like the one we looked at today that was 5 to 7 days. And so not every lesson is included because we want teachers to use this as a framework and as resources, and ideally we want teachers to be able to design their own lessons and become comfortable with being able to design their own lessons so they can adapt to their students as well. But yes, there is a lesson for every unit, at least one lesson for every unit, sometimes 2 or more lessons available.
Okay, and I noticed that at the very beginning there were many of you who weren't familiar with the model math curriculum, and it really would be well worth your time to take a look at that. They're very instructional, as well as giving us ideas for how to do a lesson relative to a certain unit. We hope that you have some suggestions for us in terms of what you might like to see, how else we can help you, and we can get some other resources to you. We have these webinars. It doesn't mean that we couldn't do others. So if you would just let us know what the topics are that would help you the most. Our interest is in being sure that good mathematics instruction is happening for the students across Illinois, and we know that you're the people to get it done. So we thank you very much for listening, and please, we'll stay on the line for just a few more minutes so that you can type in some questions, and we'll be happy to respond to them.
Linda, I was going to mention that since we had such a high percentage of people who weren't necessarily familiar with the model math curriculum resources, that perhaps looking at the archived webinar that we did last month would help some people. Is our webinar from last month available?
Okay, the other one will be up soon if it isn't already archived.
Okay. Well, that would be a good place for them to start, I think, because we detailed that in our last webinar.
Right, and perhaps if you could look back at that other slide that tells the viewers how to access the model math, to find their way on the State Board website to find that would be really helpful. The instructions there are on the screen for you, and you can find it easily there, and once you're there, the binders are by grade level down the left side of the screen, and you can choose your grade level and then look at the units. Some of the teachers with whom I work look to see how the model math curriculum writers wrote their lesson plan, and they do some comparison to see how their lesson plan compares. If you look at the achieve.org, or equip rubric, you can find a rubric for assessing, how well you have covered the basic pieces of getting a really good lesson constructed. There are assessments, I believe, written for every unit. However, not every unit is complete at this time, and so what we would really like is to get some of you all together and have you learn this process, or just hone your skills and be able to write some of these lessons to fill in some of the blanks that we have, because it's a monumental task, but it's worthwhile. This was never intended to be a curriculum that everyone has to do, but it's an option, and it kind of gives you a look at putting together those progressions to know what came before, what's coming after, and it just kind of puts it all together in one coherent package, which is what we're looking for, is focus and coherence, and then the rigor and complexity of the tasks that are included. So we do have math consultants across the state who can also help, and we really, really do appreciate your time. We know after school it's tough to come and view something for an hour, and we know we had a lot of information packed into this, so if you could actually get a hold of the archived version and take it through a step at a time slowly, that would probably be a good recommendation. And then if you have any questions, you have our email addresses, and if we don't know the answer, we're going to reach out to the people who do, and we know that there are experts who can help us get back to you. And so our goal is good math education in the state of Illinois, so carry on, and thank you for all that you do.